the data will be useful for you. So it plays a role in the schedule.
Okay, so a couple of things that we talked about yesterday in order to try to expedite the proceedings. If all of the committee members could save their questions to the end of the presentation, that would be good. If you can't, rather than raise your hand, please use the chat column, and then I'll be able to see what questions are coming up as they're coming along, and I can call on folks to present their question at that point in time. The other thing that I want everyone to know is that Greg has agreed to take questions by way of email, and for example, Paul Beyer had a question after the last meeting. He sent that question to Greg in an email. Greg has answered it, and we'll send that back to all of us so that it's shared with everybody, and then we can make it part of the public record in the next meeting and by reading it into the proceedings. So with that, does anybody have any issues with that, or is everybody comfortable with that process? And you know that next meeting will be an hour and a half. Hopefully the staff will still be able to keep their presentations to 30 minutes, but we'll have more time to go through those questions as things come along. Also in the meeting chat, you can see who has joined the group, and we'll, if that's okay with everybody, I guess we're ready to begin. And so, Greg, I'll turn it over to you to turn it over to your staff.
Thank you, Chair. Thanks a lot for that. And I did respond to Paul Beyer's question. Thank you, Paul, for the question. And we will endeavor to get that on the website and have it available for all, and we'll do that going forward. Today's presentation is the continued discussion of our wastewater treatment plant. And I think Jim Huckel and the team out there at Water Services is queued up to speak to that. I have asked, Shannon and I have asked Jim and the team to back up a slide or two and be a little more introductory about the utility, lay of the land, the overall operations of it. So forgive us in advance, if you will, to that we're going to back up a bit, but I think it'll be beneficial for all. Jim, are you ready to roll on this thing?
I'm ready if you guys are ready.
Heads are nodding, and thanks for joining us, and it's all yours.
Thank you. Good afternoon, Vice Chair White, and good afternoon, committee members. I am queuing up the presentation right now. So again, we're going to talk about infrastructure, wastewater, and the projects. Our first slide is basically where the facilities are. So Wildcat Hill Water Reclamation Plant is an end-of-the-line facility that's about 6 million gallons per day. That's what it's rated for. We actually put it through about 3.5. And as you can see, it's out near the mall, a little bit past the mall. And then Rio de Flag is a satellite plant. It's rated for 4 billion gallons per day, and we're putting through right around 2 million gallons today. The important thing to remember from this slide is that the solids from Rio de Flag are sent out to the Wildcat Reclamation Plant for treatment. So since 2010, we've been working on all sorts of energy efficiency projects between the solar fields, VFDs, variable frequency drives, and motors. We're going to give you a little bit of history. So Wildcat Hill was constructed back in 1971. It was constructed at 3 MGD, or 3 million gallons per day. It produced a Class B reclaimed water that was delivered to Continental Country Club. Biosolids were started to be disposed on site. In 1981, they expanded the facility to 6 MGD. There have been no expansions since 1981, so we're still rated at that 6 MGD. In 1993, they constructed the Rio de Flag Water Reclamation Plant. And again, it came in as a 4 MGD facility, currently running at 2, but it put out a Class A reclaimed water. And the difference is the amount of nitrogen that we take out of the water, basically just for the reclaim purposes. In 2009, Wildcat Hill was upgraded to a Class A reclaimed water plant. Again, no capacity increase, just increased the treatment capabilities of it to a Class A. There were no liquids or biosolids capacity expansions, and the only portions of that plant were upgraded. And again, we're going to talk about some of those things that weren't upgraded. In 2013, there was a consent order, and we put in a bunch of temporary solutions. The temporary solutions were supposed to be good for 5 years. They're still being used today. So it's almost 10 years later, 9 to be exact, that we're still using some of these temporary solutions. So we're going to run through a basic wastewater tour. So the first thing that happens is the preliminary treatment, and that's down in this area. Down there, we have the bar screens and grit removal systems. What they're doing is they're taking out large debris, inorganic solids, so that they don't hurt the downstream processes. The next process is the primary tank. That's that number 3 right there. It's used to take out what's called settable solids. Just like it sounds, the solids come into the tank, we slow down the flow, the solids settle to the bottom, and they head off to the digester. Then it flows over here to the secondary treatment system. This is called IFAS, Integrated Fixed Film Activated Sludge Process. And it has a very small footprint. And as I show you a picture later on of Rio, you'll see the difference. The footprint is a lot smaller because it's 2 systems in one. And that's how we got up to that Class A plus reclaimed water. From there, it moves over here to the secondary clarifiers. Again, it does the same thing as the primary clarifiers. We slow the water down, let the solids settle out. Again, those go to the digester. Clear water goes over into the next stage of treatment. The next stage is called the tertiary step, and those are the sand filters. That's down here in this number 6 area. We run through the sand filters or disc filters. Again, we're taking out particulate matter that is larger than 10 microns. From there, we go over to disinfection. The big difference between Wildcat and Rio is Wildcat uses chlorine, where Rio uses ultraviolet disinfection. And again, what we're doing is just trying to make the water safe before we put it out. From there, the fully treated water goes into either the reclaimed water distribution system or purple pipe, or it's discharged into the Rio deflag drainage. We have 2 anaerobic digesters down here marked by the A, and that's where all the solids go. So we keep those solids in there for about 15 days. It digests the solids, just like in your body, you digest the food. We break down those foods into their most carbon things or common particulates, which is carbon, which is the biosolids. We release the water. We also get a byproduct of methane gas from doing this process. From here, the digested solids are either sent up to the 2 ponds. We call these sludge storage basins, or over here to the geobags. The geobags were one of those temporary things that were put in about 9 years ago as a temporary solution for the ponds. So currently, and this is one of the slides that we gave the city council back in September, the solids treatment capacity is at 88%. The liquids capacity is at 87%. According to the Utilities Integrated Master Plan, we're supposed to, at 75%, start to identify funding, 80% begin design for increasing capacity, 85% to begin construction, and at 95% have all the construction completed. So you can see we're a little bit behind. And what all this does for us is redundancy, because we have multiple points, especially at Wildcat, for single points of failure or a potential failure. And it limits our operation and mechanical flexibility, meaning that we can't take things offline in order to fix them because we don't have a spare one to put online. As you saw, that one IFAS basin is the only treatment process out at Wildcat. So if it goes down, then the treatment process out there will not work. So what we're asking for the money for is for rehabilitation and replacement. Over the past few years, or 10 years or so, we've had budget constraints and the lack of redundancy to make the repairs. And why all this is important is because during peak flow events, during monsoon seasons, we can see 3 times the daily flows. So our current flows are right around 3.5 at Wildcat. And so during monsoon rains, we can see those flows go up to 10 to 15 million gallons per day, which makes it really hard for us to do treatment because we need that detention time, the lag time in the plant, and actually to treat the solids. So some of the other impacts to the inflow are enforcement of our industrial pretreatment permits and conservation. So over the years, conservation has done a really good job of lowering water usage in town, but it's affected the wastewater side in a detrimental way because the plants were designed to take 100 gallons per person per day, and currently we're right around 62 to 65 gallons per person per day. So now we're back into the projects. This time we prioritized them for you so that you could see which ones were high on our list. And we're going to go through them in order so that we keep on track. So the first one is for the digester complex expansion. It's our priority number one. They were installed in 1983, and the mixing system was upgraded in 2008. The solids treatment capacity at the digesters is 88%. We're really high on those, and we have to have that minimum of 15 days in the digesters, or else we will not be able to make Class B biosolids. If we can't make Class B biosolids, then we have to take it out to a landfill. So that's why this is so critical for our operation. And it's part of a three-part plan. The first part is to build the digesters. The second part is to put in a unit to dewater. And then there's a third portion, which is going to be solar drying. So we're going to be very energy efficiency on that one, where we can dry the solids and still apply them to the field. But it also gives us the opportunity to use it for biochar or use it for top cover out at the landfill. Oops, sorry. And the project is estimated by about 16 million. The annual inflation rate is 20%. We kind of talked about that last week, where I've talked to some of my colleagues in both consulting and vendors, and they're seeing a 20% increase on all projects currently. And the risk for this one is very high. If we don't get this done, then we won't be able to treat the solids at the plant, which is going to cost us more money in the long run. The second project is the Headworks Rehabilitation. Again, Headworks was constructed in 1983. And whenever we put that in, we put in 3 bar screens. In 2012, we replaced 2 of the bar screens, but we didn't replace the third one. We're also going to install some flow metering for inflow monitoring. Currently, the flow metering system that's there was put in a manhole, and it's a temporary thing, and we're having a whole lot of problems trying to get a consistent flow. And that's really important for us to know how much flow is coming in, because that's how we do our process control. Think about it as like your speedometer on your car. If it's not working, it's kind of difficult to tell how fast you're going down the highway. We're also going to put in a bypass around this building while we're doing the work in the building, which ties into the primary effluent pump station project, which we're going to do next. And what it does is it allows us to do both of those projects and be as efficient as we possibly can. So this will improve plant operations. Currently, that third bar screen is offline. It doesn't work anymore. Again, it's almost 30 years old. It has lived its life. This also creates resiliency in the plants to help treat higher flows, get more accurate flow measurements. And the estimated cost for this project is right around $5 million. And again, that annual inflation is never going to change. It's always going to be 20%, but the risk is very high. Currently, we have to have staff go down there during high flows, during monsoon rains, and break that bar screen by hand. And so we almost have to staff the plant 24 hours a day during high flow events. So this is the primary effluent pump station. It's our priority number 3, and it has to be done after we do that other project. And what we did here is we gave you a schematic. You can see at the bottom down here, we have 2 smaller pumps. Whenever they upgraded the plant back in 2008, they did not do anything with the existing pump station. So our pump curve is very inefficient. The pumps either have to pump too hard or not hard enough, and they're cycling on and off, which causes problems in the plant. This project puts in 2 smaller pumps for normal flows, and then these 4 larger pumps for larger flows. These 2 smaller pumps can also be increased in size in the future whenever the flows deem that to upgrade them to a higher flow. Again, this project is right around $5 million, and it's a high priority because during high flow events, the current pumping station runs all 4 pumps. If one of those pumps happen to fail, then it's going to cause the flow to start to back up, back into the plant. It can flood our tunnels and start to come up around the plant. This project also supports our carbon neutrality plan because these pumps will be much more efficient. Our next project, this one is at the Rio de Flag. It's a bar screen project, just like over at Wildcat, except for the difference is these bar screens have been maintained very well over the last 30 years. So we had a contractor come out right before COVID and inspect them. And they said that if we can get in there and make some improvements, that we don't have to pull these bar screens all the way out of the system and put in new ones, which is a big cost savings for us. So, and the reason that this is critical is we're planning on increasing the flows to the Rio facility. And for that, we have to have both of these bar screens online. So this supports our resiliency and redundancy initiatives. This project is 1.5 million. And again, the risk is very high because, again, they're 30 years old. They're at the end of their useful life until we can get them fixed. The next project, again, is over here at the Rio de Flag. It's our priority 5. These are the generators and switch gears. So the reason for having those here is as we start to increase that flow to Rio, the Wildcat plant will see a reduction in flow. And if, for whatever reason, if we had a power failure and all the flow then suddenly got sent out to Wildcat, Wildcat can't handle it. I kind of compare it to driving the Titanic. We can see the iceberg coming, but we just can't turn. So it's really important to have these new generators and switch gears in place before something bad happens. And we talked about this a little bit last time about, you know, we've lost power at the Rio before for 6 or 7 hours. If we go much longer than that, our bugs will start to die. And then it takes us 3 to 6 weeks to bring that plant back up online. During that time, we have to send all that flow out to Wildcat, and it puts a big burden on them. And again, the facility uses oxygen produced by compressors, which have to run off the electricity. But the whole plant runs off of electricity. If we don't have power, I can't even pump the water into the plant. So again, this supports our resiliency. And just as we think about this, I was working at a plant 10 or 15 years ago, and they built a brand new plant for $33 million. They did not put in generators. 2 weeks after they put it online, the power failed. The next day, the engineers were out trying to figure out how to put in generators. So the estimated cost for this project is $2.16 million. But the risk is a little bit more on the medium side, not on the high side, because power failures are rare, but they do happen. The next project is back over at the Wildcat Headworks. And at the Headworks, we have a motor control center. The motor control center was put in 1971, which makes it, 40 years old, 50 years old. Most electrical panels are good for 25 to 30 years. So these ones have been long past overdue. We're going to replace the MCCs with new units to meet the new electrical codes. It was brought up as part of our arc flash study, and our arc flash study is something that we have to do every 5 years to make sure that our electrical equipment is in good shape. And again, they made note in their report that this equipment is well beyond its useful life. And it's critical. This part of the plant, if that MCC or motor control center fails, well, not only do we lose the headworks, but we also lose that primary effluent pump station. Without that, we can't pump up into IFAS. And again, it's the same thing as if that pump station goes down, we can flood the tunnels and have certain other issues around the plant. With the new MCCs, it'll also help with our energy improvement because we will be able to see the power usage from each of the pieces of equipment so that we can watch for trends and see whenever things are starting to go bad. And the estimated cost for this project is about $2.4 million. And the risk for this one is high. And I know the last one was medium at 5 and this one's high at 6, but that's just kind of how it worked out. So the next one is, again, a motor control center, only this one is over at Rio. So Rios are right around 30 years old, so it's time for us to start thinking about replacing them. And again, same thing. We want to bring them up to electrical code. We want to make sure that we have redundancy and resiliency. It was again brought up during our arc flash study that they are nearing the end of their useful life. And again, all of our MCCs are critical. We can't afford to lose one, because if we lose certain parts of the plant, then we can't effectively treat the wastewater. And that's why it's important for us to have these projects done. The next one is out at Wildcat, and it's a Septuagint grease receiving station. It's a priority 8, and the risk is medium on this one. So the existing Septuagint receiving station was installed in the mid 2000s, and it's there for, and the Septuagint part is there for county residents. The grease station has no pre-treatment on it. They can dump in whatever they want, and so that this project is going to be helping us stop people from dumping things that they shouldn't dump into the sewers. So, and again, the grease is only accepted within a 20-mile radius, where septic is countywide. And as we all know, we're the second largest county in the country. So that's a lot of septic that comes into the facility. The issues that we've had in the past is people have brought in things that are not compatible with wastewater treatment, which causes major upset at the Wildcat facility and causes the operation staff hours spent cleaning out pumps and equipment, cleaning up foam, because somebody's dumped something that they shouldn't have dumped. And right now we have no control over that. It's critical that adding this system, because we're going to add new probes into it. So what we're going to do is, if somebody actually dumps something that they're not supposed to, it'll go dump into a spare pit, which they'll have to pull out and clean while it shuts down the system, purges out the system, so that we don't hurt our existing equipment. And again, this creates resiliency. This project is about $5.4 million, and the risk is medium. So this is project number 9. This is out at Wildcat. And I talked about the digester gas, or methane gas, that we produce, which is basically just natural gas. That's what this project is for. What we're going to do is we're going to put in Cogen units, and they're combined heat and power. So we're going to go get both electricity and heat for the buildings and for the digesters from these units. The heat will help support digester operations, reduce our natural gas usage. The 2 units will help create redundancy and provide for alternative fuel during emergency power outages. The project uses, like I said, the biogas, methane, or natural gas, however you want to look at it, that we naturally create in the anaerobic digester. So this is an energy improvement project, because it offsets our electrical use and our natural gas use by generating electricity and heat for the plant. And it's our largest carbon neutrality project that we've had so far. So the project costs about $4.5 million, but the risk is low, because if we don't do it, we continue on as we are. And project number 10. Over here at the Rio de Flag, we want to install some small turbo blowers. Back in 2017, whenever we installed the other blowers, they were just replaced in kind. And so the larger air blowers put out too much air. So it makes it hard for us to run the plant, because our dissolved oxygen to feed our bugs, we try to keep it around 2 milligrams per liter, and it's up around 9 and 10 at night. And it negatively impacts the biological system, and it creates problems within the system. This project was identified through modeling. We use a modeling program called BioWin, and just through plant operations and in the 2019 master plan. This project would help balance the operation of this facility. And again, these blowers are much more efficient than the ones we currently have, so we would see a reduction in power. The estimated cost for this is about $1.44 million, but the risk is low, because we already have the new blowers, but it would be very helpful for the staff to have. So project benefits and community impacts. These projects were made to obtain, or were designed to help maintain current standards and technology. This is not an increase. It's not a decrease. It's just to maintain the current standards using newer technology. They do not increase capacity or eliminate the future need for a new plant. They address some of the key focus areas, which are below. They reduce the risk. As I talked about the bar screens, increase safety for staff and to the facility. They maintain compliance with both ADEQ and US EPA regulations. They create redundancy, resiliency, energy improvements. A lot of these projects were mentioned in the master plan, and they also create operational improvements to make it easier for the operators to run the facility.
Hey
If
Jim,
we-
this is Gary. Can I interject something real quick?
Sure.
Can you go back one slide?
I most definitely can.
Thank you. So I just wanted to hit on one thing. By the way, my name's Gary Miller. I'm the new Water Services Engineering Section Director. When Jim's talking about maintaining compliance with ADQ and other regulations, that particular bullet point is in relationship to our treatment of biosolids. And some of the other projects listed, but one of the things I wanted to point out is because we treat so much more biosolids than the plant was originally designed for, we're really getting limited on that capacity. And as Jim had alluded to previously, we need to have the necessary equipment to treat the additional biosolids that we're seeing in our processes now because of conservation and because of just general growth within the city. So again, like Jim said, we're not increasing the capacity of the plant. We are maintaining our capacity of treatment, but we're seeing a higher concentration of biosolids, and we need some of that work to maintain that compliance. So thanks, Jim. I just wanted to put a finer point on that.
No problem. Thank you, Gary. Appreciate you coming in. I needed a drink of water anyway. So some of the negative impacts, if this isn't addressed, and just so everybody knows, the two pictures over there on the left-hand side, those are just stock photos. Those are nothing that we would ever want to see coming out of our facilities. If the reclamation plant shut down, the facilities are flooded and damaged. We had that happen back in 2016. We flooded one of our tunnels, and it cost us $150,000 to replace motors. Luckily enough, we were able to get the plant back online the same day, and we were fully operational within 3 days. A lot of other treatment plants can't say that. So we have a really good staff that helps make these plants run really well. The wastewater could potentially contaminate local environments, non-compliance from regulatory industries, loss of trust from the community, and that's a big one for us. You know, we work hard to put out a quality effluent, so we don't want to lose anybody's trust, and we would also lose the reclaimed water supply. And as I was talking earlier, I was going to show you a picture of Rio. So this is the Rio facility. These two are the primary clarifiers. These are the aeration basins, which are almost twice as big as the ones at IFAS or over at Wildcat. And these are the secondary clarifiers. And again, we have both circular and rectangular clarifiers. They actually work the same. This is also a solar field. And on top of the aeration booth, we have a solar field. And then over in here, we have a filter building, blowers, and this is the admin building. So we want to continue to meet council's goals and objectives. So from the PBB, we want to ensure that we ensure safety and health of the community, sustainable and innovative infrastructure, and high performing governance. From the regional plan, we're looking at environmental and conservation goals, energy efficiency goals, and again, environmental and conservation goals. I know that's in there twice, and also to help support water resources. And then this last slide is just a breakdown, since instead of getting it all onto one slide. So as you can see, I've installed or put in the risk factors, potential other funding options that we might have. The one that we might have, the only one that we really have is the Cogen, where we might have a grant opportunity. I put in the years that we're looking to start these projects, and it goes by fiscal year. So that would be July 1st of the first date that you see, so 22, 23. And then the capital need. So I put all the prices all in this column. So it's a total of about $46,972,000. But we do have some funding available through our capital improvement plan, and to the amount of $1.872 million. So I wanted to put that in there. And then I also gave you the inflation price. So as the longer that we delay the projects, the more those prices are going to go up. So that last column uses the fiscal year that we're planning on starting those projects and added the money in for those. The infrastructure bill and grants availability have not been determined at this time and may not align with our timing needs. So with that, I will take any questions.
All right, well, I think, I mean, I wrote down probably 5 or 6 questions that I have myself. But I think the place to start would be with Paul's question that he sent out that he wrote to Greg and Greg answered since it came from the last meeting. And we could go there. In the chat, I have a question from John Daly, and that's it for now in the chat. And then we can open it up. So can we start with Paul's question?
Thank you, Chair. I can take this one and Paul can jump in as well, but I sent to the budget, pardon me, to this team, the bond committee, Paul's question and my response to it. And I want to pull that up and generalize it now very quickly, but you have a little more detail in the email that should be in your inbox. And going forward, we'll try to get answers out quickly. I kind of like this suggested protocol of doing things in a written format. Bear with me while I pull this up. The question pertained to the discussion that kind of occurred last week on this topic, and we drifted into the subject of rates, utility rates, and specifically the question was, you know, at the time, can the rates absorb these capital costs? I jumped in at the end of the meeting and said, well, not really. We generally fall short of the capital costs for a variety of reasons. And that was Paul's question. And Paul, thank you for the question. And then I attempted to provide that variety of reasons. It is not an exhaustive list, and my comments are very general. Others can speak to this with more specificity. Generally speaking, and we noted that this operation does function as an enterprise, which means it's a government-owned business, which means we try to cover costs with the revenues generated within the utility. But when we speak of significant upgrades like this, and Jim shared with us that the timeline when those upgrades have occurred, it's not every year, is actually very sporadically over time. They do almost always require some sort of outside funding because the utility simply cannot absorb those costs for reasons that I laid out. First, the utility capital needs for these upgrades frequently is outpaces rather the revenues that are derived from the rates. We cannot save up money to cover these costs. You're looking at, and this is a great segue into the graph you're looking at that Jim put up at the end here. At the bottom of that, you see current capital allocation for wastewater projects, about 10 million. A very good illustration of that point. It will not cover the entirety of the capital costs. We do have some capital funding that we allow for, but it never covers the scope and the magnitude of these big changes. Number two, the utility rate structures almost always, they cover operational costs, but again, not always the entirety of our capital upgrade needs. Number three, and Jim touched on this, the rapidly evolving regulatory landscape has resulted in some costly improvements that necessitate additional funding strategies. That's not to say that these regulations are bad. As I noted last week, we want to be good stewards and do our best to meet the ever-changing regulatory requirements. A lot of this is about that. Number four, Jim touched on this with the conservation efforts on water. We have seen less dilution in our wastewater system, more solids, more organics, with that more biological oxygen demands, the BODs. You hear about that every now and then. So it places a little bit more burden on this particular utility. Number 5, in tourist-based economies, and you can include Flagstaff in that, we do rely on utility usage that is occurring that is not covered by our ratepayers. As a general comment, we have to reach peak uses for high tourist demands that go well beyond our localized capacity needs. And finally, and I think specific to this group, the debt issuance within the enterprise is a tool that we see used with growing regularity. We cannot save and pay to cover these costs, but what we can do on occasion is borrow and then pay back through a debt issuance. And that's the reason this is all in front of you now. So I'll stop with that, Mr. Chair, and you can address other questions as they come up. Thank you.
Okay. One quick observation, and that is, at this point in time, looking at the bond request for just this area, and seeing council direction to kind of stay within the $70 million range, we're looking at 60 million of that just for wastewater. It strikes me as trying to get a lot of things done that needed to be done over a period of time, at the as the deadlines draw near. We have a question that came from John Daly, and that question is, what is the annual value of the power and heat produced by the biogas CHP system?
And so we had a Cogen installed back in, I think it was around 2006. And whenever it was functional, we saw a reduction of about half of our power usage. Now, it was not tied into the heat system. Back then, that wasn't the way that things were run. The new systems that we're looking at probably taking our boiler offline because it runs year round because we have to heat the digester. Digesters are a lot like people. They have to be about 98.5 degrees year round. So we have to add heat into it in the summertime. During the summertime, we wouldn't be running our boiler at all. All of our heat would come from there. And we're hoping in the wintertime, we'd see about the same thing. As far as the electrical usage, I'm estimating right now that we could probably cut our APS bill anywhere from 25 to 50%.
Okay. Paul has raised his hand, and I guess it's only fair to ask Paul if Greg's answer was helpful at all. Did it answer everything that you wanted it to answer?
Sure. Yeah, it was very helpful, and I thank you very much for doing it. But maybe just to follow up, I guess my thought was, since I pay a little water and sewer every month as part of my what we do here, is that could we increase the water rates to cover part of this? Like we said here, we've got 60 million. And maybe instead of asking the voters of Flagstaff to increase our sales taxes to pay for all of this, could we make it a little more sellable by maybe splitting the cost between ratepayers and sales tax?
I can address that, Greg. Again, this is Gary Miller, Water Services Engineering Section Director. I don't remember the date of the last rate study that we did, but it has been some time. I want to say 2016, 2017. Jim might remember. And that rate study is out of date. It needs to be updated. We are actually in the process of updating or seeking a new rate study today. But that's going to take some time before those rates can be implemented. When we reevaluate rates, typically there's a time frame in which those rates are introduced. So it can take place over the course of multiple years. And Rick Tatter could probably speak more eloquently to that than I can, but we are in the process of looking at a new rate study.
Okay, thanks. The second question that I see in the chat comes from Ron Ghetto, and that is, can we get an explanation of the inflation column? These figures do not consistently represent 20% as a committee. We should also have our presenters standardize their inflation assumption. Police and fire were at 15. Now we see 20. This kind of got answered last time with the 20, but if someone would like to make a further explanation of the inflation column to try to help Ron out, that would be great.
I can do that. So currently,
Hey, Jim, this is Andy. Let me jump in.
Okay.
Hi, everyone. This is Andy Bertelson. I'm the Water Services Director for the City of Flagstaff. Good to see everyone. And Ron, you raise a very good point. And I think having a standard for how we calculate inflation for capital projects is needed and necessary. And Jim can probably speak to it better than I. He's probably looking at his industry standards and the publications that get put out in the wastewater world and what that inflationary amount is looking like. We know that we've had significant increases, particularly with material cost, et cetera, shipping cost, supply chain issues associated with the global pandemic, et cetera. How will that continue? How will inflation that we're seeing on that national scale factor into that? So very good point. Gary answered the question about our rate study. And I think when we look at operating our utility and our business, so to speak, within the city of Flagstaff, we look at that combination of funding sources and how we're utilizing those funding sources to operate that utility. And so I think what Jim has been able to do, and we worked with this as a staff earlier this week, is you'll note that he has per each project on this slide that we're looking at, 1, 2, 3, 4, 5, 6. So he's essentially said, as a matter of priority, here's what the priorities are. And then next to that is the column of risk. And so I think if you start to add up the amounts for those high risk top priority, you know, you're starting to venture into that $25-30 million range. The total ask is certainly more significant than that. And we know that in order to operate that utility, we have to look at all of our funding sources, whether there's going to be some environmental infrastructure grants that are being released through the federal level, filtering through the state, WIFA, Water Infrastructure Finance Authority, this bonding opportunity that we have. We know that we have this resiliency and redundancy issue in our wastewater treatment plants. We're also looking at the longer term capacity issues. And in terms of gallons per day, average gallons per day, Jim spoke to that. We're starting to venture towards that maximum capacity. He outlined the risk of, you know, if we have a plant failure, that's not a good thing for our community, for a wastewater treatment plant failure. So Greg commented that we have Rick Tatter. I don't know if he's on the line to speak to the inflationary issue, but just wanted to kind of both answer that question and then further elaborate on the larger question of city council direction. We have this threshold in which we're working. I think that's kind of why we, as a water services staff and in wastewater, looked at that level of risk, and then in doing so also looked at a ranking of priority. And so if we need to further prioritize these projects and have that discussion with you, we're prepared to do so. So Jim, thank you for allowing me to butt right in. You know, I have a tendency to do that sometimes, but it's just, I just wanted to say a few things in relation to that. So thank you.
Andy, your temptation to butt right in is only surpassed by my very own. So I want to continue with Ron's questions. Ron's second question is there an ROI, a return on investment on the Cogen investment? And he also asked, can we store the solar power that Rio is generating and avoid the purchase of an expensive generator?
so I'll answer the second question first. The answer is no. We don't currently have the capacity to put in batteries. We don't have the storage for batteries. And I don't think that was a part of the original system. That system at Rio currently supplies about anywhere from 14 to 20%, depending on how much sun we get, of the power here for Rio. So it's been a great benefit for us, but we don't have a way to store it. And then the first question was on the cogeneration and the ROI. And because we're still at 90% plans, we're still working on the return on investment. It's a longer return on investment because of the cost of the project. And we're still trying to figure out exactly how much energy and heat that we're going to get from that project.
Okay, so Greg has started to answer some of these questions, so has Shannon. Greg's one answer that Greg has put up is that the projects are prioritized and it's likely they will not be able to be funded in one funding request. Also, there is an approximately 10 million in existing capital, which we see on the chart. And then Shannon Anderson has said that sometimes inflation is different in each project because of what we're seeing in the different industries. And then Greg came back to say again, Rick Tatter can also speak to the debt structure being considered, not a sales tax, but rather a debt within the property tax structure. The debt payment can be paid back by the water utility over time. And that takes care of the questions and some of the partial answers that we've seen. Are there any others out there amongst committee members that that want to raise their hand at this point? Paul.
Yeah, thank you. This is a lot to digest. I just typed one in, but I'll go ahead and ask it. I actually have two, but the first, that seepage and grease receiving improvement is a big dollar item. And I assume that most of these people who are private citizens bringing their sewage to be discharged are probably not city taxpayers, or they'd be on the sewer, on our sewer system. So I'm wondering, does the county help pay for this, or should they? You know, I guess, you know, who are these people and why are we paying to do this?
So
you know, I'm a generous guy, but I just want to know.
So we entered an agreement with the county back in the early 2000s, and they did help originally build the original septic receiving station. I think the grease receiving station came in 2008, and I don't know a whole lot about it, but I can tell you that it's just an open pit that they come in and it's a tank that we have covered, but they just come in and dump their grease into it. And the individual people don't bring it in. There's septic haulers that run all around the county who bring the septic to us in like 3,000 gallon tankers. The reason that I think the Flagstaff is doing it is because we're centralized. So we're an easy place to get to. And again, the county did help pay for the original project.
Okay, I guess just one other question too, as we do all of this, some of these things, like we got to do them, but I'm just wondering, are these going to be flexible enough, all our designs, to accommodate changes that might occur in our water treatment standards? You know, everything we discharge does go into the sea aquifer, and we pump from it, and other communities pump from it as well. We do know that sea aquifer flows to the northeast, but we don't know too much else. We do have 6 pumping stations, I understand, that are downstream from our discharge points. So eventually, some of the compounds of emerging concern may come into our drinking water or the water that we pump. There may be new standards. Just how much are we anticipating possible increases in standards where A+ now becomes B, and we got to search for A. You know, so how much flexibility do we have, and how much should we be thinking about that as we do these, so that we don't say, oops, we should have asked for more and done a better job back in 2022.
So we'll take the first one, the digester complex. That one is being built in a location where a future facility is supposed to go, and 2 more of those digesters, depending on how growth goes. The Headworks project is looking forward to, and I'm going to combine Headworks and PEP's, primary effluent pump station. Those 2 projects are both looking at being able to pump to the new facility and being able to reuse those facilities for another 15 to 20 years before they'd have to be upgraded again. Again, passing the higher cost of replacing those facilities on to, for once we're done paying for this bond. The bar screens, that one is just a rehabilitation project. The generators is another one that's looking out for that 20 years. If we had a severe snowstorm, or even last year, whenever, or not, it was either last year or the year before, sometime during COVID, Phoenix was using so much power because of the heat. They called us up and said, hey, we're going to turn off your power for a while because we can't send it up there anymore. So without those generators, Rio would have been down at that time. The motor control centers are pretty much rehabilitations and rehabs. The Septuagint grease receiving, that one is looking forward and helping to protect the facility from, you know, any kind of bad things that might be coming in. Cogeneration, again, looking towards the future. And the turbo blowers, kind of, sort of, it's more of an energy efficiency project. So, but every one of our projects, we look at regulations. That's always one of the things we look at. We look at future regulations, current regulations, the trends around the country. Phosphorus is really big on the East Coast and the Midwest, but not out here on the West Coast. So we don't worry about phosphorus as much, but we're already treating for it. So we're already in pretty good shape. But every project is always looking forward to how we can improve. And even the future facility that we're talking about is talking about putting in membrane units, and they will get us almost a drinking water quality just by putting those in. A couple more steps, we could actually do direct potable reuse or just putting it back into the streams or pumping it down into the aquifers.
Okay. All right. Well,
Does that
thank you.
answer your question?
Yeah, that was very helpful.
Thank you.
So Ron also comes back with some mathematics some arithmetic that he's done, and he shows that 10.7 million of 46.9 million is actually 23%. So I don't know if anybody wants to account for that, or if that helps us squeeze out some more dollars to be used somewhere else. And then he also asks, why ask for money for a project not starting until fiscal year 26-27? And are you assuming that this is your last shot to fund it?
Chairman White, thank you. I'll go ahead and start the answer, and Jim, you'll probably need to jump in. But I've been thinking about your question, just reading the chat, Ron, and notice why ask for money for a project not starting until FY 26-27. And obviously, these are pretty large scale or major projects, particularly as you look at the level of funding. And so with that comes a lot of preparation planning, working with engineers on project design, and in doing that. So if we're looking at a project that would start in FY 26-27, we're now going into FY 22-23, that project being a couple of years off. We'll need that time frame in which to plan, to design, to engineer, and then ultimately implement. So I understand it's kind of moving at the speed of government, so to speak, but these are large scale projects for us at the city. And with that, it's securing the funding and then utilizing that funding to move forward towards implementation. And then in terms of the inflation, thanks for running those numbers. And Jim, I'll let you answer that. And sometimes we do need to beat the budget until it confesses. And so we'll look at that going forward.
So the difference might be, as I based it on which fiscal year it was going to start, and we might have changed some of these numbers, and I might not have gone back and rerun the math. So I'm more than happy to go back and rerun the math and correct those numbers.
And Jim, I wanted to point out, if you look at the septage grease receiving line item on there, you'll notice that the inflation is almost double the original capital need. That's because of the fiscal year that it's programmed for. And so the reason for the difference, or more than 20% increase in inflation, it's because it's based off of the fiscal year that it's planned for. So if it's planned sooner, there's a lower inflationary rate because we're only planning for 1 year of inflation. But if it's planned for 4 or 5 years out, there's 4 or 5 years of worth of inflation incorporated into that. So that's why those numbers are different, and that's why the overall total is greater than 20%.
And Gary, did you want to touch on the reason why the projects are staggered a little bit, like what you and I had talked about? Because we can only do so many projects in a year.
Yeah, so that kind of speaks to Andy's response earlier. It just provides another reason as to why these projects are spread out over the course of several years. And we have a very limited capacity in the amount of projects we can deliver just based off of you know, the number of project managers we have available within the city to deliver projects. So that's another reason that a lot of these projects are spaced out the way they are.
Mr. Chair, it's Greg Clifton here. May I offer a suggestion?
Please do.
We're at the close of the hour. It's been a very good discussion. Thank you for that. Thank you to everybody. I'm seeing enough interest on the subject of compounding inflation, and thank you, Ron, and others for jumping in on that. That perhaps that might be a question we could also address between now and the next meeting with a little bit more of a clarifying answer. And we'll try to wrap in last week's previous discussions on the inflation used by public safety versus that we're seeing in front of us. We'll gladly give that one a little bit more thought and cover that in an answer to the group. Ron, would that be okay? Because I know it looks like this is a matter of high interest. Okay, thumbs up. And I do want to thank the presenters for flying through this presentation and backing up and giving us some introductory slides. I found that very beneficial, very technical topic, but we went from high level to in-depth and did so at a rapid pace. That's much appreciated. Starting the next week, we will, the next meeting next week, we will go to an hour and a half, and I think there'll be just as much content, but we will not be having to talk as fast, and we appreciate the opportunity to do that. So with that, Mr. Chair and the entire committee, I'll wrap up what I have to say, and you could have any closing comments of your own. Thank you.
Okay. Thanks. Does anybody else have anything that they want to bring out now quickly for the good of the order? I had two questions that I have added to the chat, and what I guess I'll do is make sure that I email those to you, Greg, for the beginning of the next session, so that we won't take any more time now. And with that, I would welcome anybody else's comments for the good of the order. Anything at this point in time from anybody? Are there any immediate questions that we have to deal with right now? Thanks to the staff for being able to try to come back and answer some of those. I think also that we have I guess an awful lot of details to wade through when we come down to this committee starting to look at prioritizing and recommendations to the city council. I would also like to suggest that it might be within the purview of this committee to make recommendations that go above and beyond the bonding process to the council. For example, some things like trying to figure out how to spread some of the projects over a period of time where we bond later on a more concise or maybe compact bonding package that includes some wastewater in the following years, as well as trying to play catch up right now. We also may want to make recommendations regarding certain fees that might need to be increased to try to split the cost of upgrading systems that will apply to everybody, and some fees that will apply to new development, covering some of the cost of these upgrades that they are making us need to do in terms of capacity, things along those lines. So anybody else want to come in with a question? If not, then please address them to Greg, and he will answer them for all of us. And we will adjourn, I guess, at this point in time.
Wish everybody a nice evening. Thank you for a very thoughtful discussion. Thank you to the presenters, and thank you to the committee.
Thank you all for listening. Appreciate your time.
You bet. Okay. I guess we're done. Thanks.
Thank you all.
Bye.